Java patterns and practices for serverless applications. I didn't want to tell you best practices because best practices, it is too short. So I'm doing this for a couple of years, and after a couple of years, you cannot have already best practices. But what I did, I compiled the most asked questions and tried to answer them and gave a name for it. So this is what I did, and it worked well in my project. And even though the last 2 weeks I got lots of questions regarding how to ship Java in an archive and so forth. I will use as an example AWS, because right now all my projects are AWS. But 2 years ago I did a lot with Azure, and Azure will come back. It's just I'm a singleton. I'm working all the time with Java, so that's the problem. I cannot be on all clouds at the same time. And I also heard good things about Oracle Cloud, and yeah. So I like Java. That's wrong. Unfortunately, I don't have a doc. I had a doc, but I don't have it anymore. And the name was not Java. So so you see, nobody's perfect. But if I get next doc, maybe I would call it Java or JVM or at least Duke. Also a beautiful name for a doc. Okay. I have a blog. Maybe if you like, you can join the Airhacks Discord. It's a lots of fun. There are lots of people you already know. So and what I'm doing right now, it was accident, but I have almost daily shorts about Java on my YouTube channel. So if you like, you can also watch that. So also a podcast. Maybe one is the recent one is about Lambda and Snapstart. So there are lots of podcasts also Java related. Any questions left? Yeah, Hex TV. Once a month, I'm answering all the questions. Some workshops in summer, but this is my Discord. But now let's start with the content. And I would say this is not a pattern, but this is what happens in the cloud. And what how I call it is cost-driven architectures. So I think this is, I would show it was a general principle. So especially in larger enterprises, if you start in the cloud, you have to consider cost first. You cannot just pick whatever technology you like, because maybe you cannot pay for it and your project will die. So what I do, I spend most of my time actually in the calculator. For instance, on AWS, there is a URI. I know it already. It's called calculator.aws. And this is how my project starts, and I get lots of questions regarding Lambda. And this is the I already know even the I already know the result. What will happen. So if I go here to Frankfurt, and this is the most common question. Okay, is Java usable in the cloud? I say, okay, Frankfurt. I would like to run Lambda because it's the most serverless service, I would say. Architecture ARM, a little bit cost efficient and a little bit cheaper. 2 transactions per second. This is, I think, fair enough. 100 millisecond. 100 millisecond is the duration of a call. The longer, the more you have to pay. And amount of memory allocated, 1.7 gig is roughly 1 CPU. So, and I think it will cost me roughly $7 or $8 or something like this. And here it is $7. So it means if you build a microservice, what I show you in a second, it would run 24/7 the entire month. 2 transactions per second, 1 CPU with 1.8 gigabyte of RAM, you will pay roughly, €8 or €7. It can, of course, change. Okay, so this is the first question, and then people are surprised. Oh, actually, this is working. The same you can do, with Kubernetes. And Kubernetes, you will pay €75 just for the control plane a month. So without any workers. And then there is a middle things, which is called, for instance, Fargate. Fargate is serverless, ECS Fargate or a Fargate on Kubernetes, EKS. And you will pay a little bit less. Sorry, I'm not looking at the camera because sometimes I see the airplanes here. So I'm a little bit distracted. So, but no docs here so far. Okay, now, cost-driven architecture. This was that. Green IT. So also interesting this year. I completely overlooked that, but green IT is a huge hype, at least in Germany. So in all projects, I get asked, what about green IT? So last week, I just, first I joked about that, but if I mentioned green IT, everyone listened. So, okay, there are interests here. Last week in a workshop, I mentioned green IT, and a company said, okay, we really have to do this. Good news, very good news. This is a report from Google. So the link is here below. I will show you the slides later. And what you see here is that Java is number 5, and regarding energy efficiency, if you're running on AWS in Frankfurt, To my knowledge, Frankfurt is 95% renewable. So I would say we are pretty good, right? So ADA would be better, but this is hard to find programmers who know ADA. Rust is a true competitor, but Rust, I would say, in Rust, it is a lot harder to build business applications than with Java. I would say Java is that simple. And what's interesting, if you consider Ruby, this is like, orders of magnitude less energy efficient as Java. So if you are green and you like to be efficient, take a look, at Green IT or Green IT at Java. And what it means, Java is energy efficient. Java is also really fast. So Java is faster than Python and Node.js. So it means if you are not, you have no interest in being green, but you would like to save costs, Java is also an interesting option because you pay for gigabyte second. It means, the longer something takes, the more expensive it gets. Okay. This is my only slide, actually, I created for you because I would like to spend a little bit more time in code. But what I would like, this is the patents of patents. I mean, I invented the names yesterday because I don't need names in my project. We just do this. But I get so many questions about that. And it is always good to have a title or a name for a concept. So the first is infrastructural resources. And for me, it was the first time it is slower because the cold start, but this is the entire microservice application. So it was slower, but the subsequent calls should be fast. And I'm on the, so it is like 100, 122 milliseconds. So it is okay for one CPU, an entire microservice, Quarkus apps running as Lambda. Yeah, it is a little bit more than 100 milliseconds. So you will pay, not €7, but €9 if you call it the entire time, 2 transactions per second. Of course, if there is a database, it will take longer, and then it's going to be more expensive. So as I said, cost-driven architectures, you will spend, more time in the calculator then, right? Because if you have a really heavy traffic, then something like Fargate can be more cost effective than Lambda, of course. I don't know if there are any questions. The moderator can always is free to ask me and interrupt me. If not, I will do it at the end. So it depends on you. I like questions. So okay, now let's see. So we covered the microservice as a function. And by the way, I forgot about that. I wrote an article on AWS blog. If you search for Adam Bean, Coreto, functions, hopefully AWS and microservice. Hopefully I forgot the title, but maybe we'll find it. Here is it. And I described actually this in the Coreto blog. It took a while until it was published because I think it had to be reviewed a lot because my ideas are unusual, because I propagated large monolithic functions because it's simple. It's the same what I do actually outside the cloud. So I start with a monolith first, and then if you have problems, then build microservices. You don't have to start with hundreds of functions, and then think about what is my release strategy, what happens if one function changes. So if you have one function, less problems. Okay, now this is the by far, so the microservice as function, lots of questions, but this questions I get all the time. How I package the application. So, and I created a sample application for you, and to show you this, how I package larger applications, because this is, I use this setup in production a little bit, changed, but there's only one function. But I show you a more interesting application. So dogs rock is already, I didn't want it to say, cats don't rock. So I was nice and just said, dogs rock. This is regarding the, the donation. So always choose one, what I understood. So we have serverless archive. This is the pattern. And let's go to Lambda's Quarkus here. It's the same setup. CDK is the entire deployment, and Lambda is the business logic. So I would just to open both and show you what happens. So this is a little bit more sophisticated application. So what happens here, I have a write and listener. I will call it in real world, like maybe like flights and pilots. Listener and writer is just, for the show, easier what happens. But it is actually a defect in real world, because I wouldn't like to name the packages after, technical things. I would rather call it pilots, flights, conference schedule, something from the business domain. Okay, so I have here the greetings resource here. As you can see, micro profile application again with the greeter, and the greeter gets injected. So I changed the code yesterday, improved it a bit, and it uses S3 store. So there's an S3 store. There is no dependency injection involved, just a Java interface with a simple, S3 client. I have here write, which, writes a key value to a bucket. This is like very similar to writing, to a hash map. No difference actually. So that's all. So then, so what is the Lambda, writes to an S3 store? And so, okay, nothing unusual. What's unusual is I have here an S3 listener, and this is a proper Lambda, an asynchronous Lambda. And it listens to the S3 event and just prints that out. So, maybe this Lambda would like to read the data from the bucket. So I could actually, both Lambdas could use the shared interface, Java interface. One will write and the other one will read. So this is very common in my projects, but it already answers the question. What I'm doing here, I have a one Maven, let's call it monorepo, and it comprises 10, 15 Lambdas. In the back, in the old war days, web archives. So we had, one war with multiple endpoints. We could have a SOAP servlet, JSF servlet, and even JAX-RS, everything together. No difference in the cloud. Absolutely not. So what usually happens, we have one entry point. This is the Quarkus quasi-synchronous lambda, which exposes, HTTP endpoints to the outside world. And all other lambdas are asynchronous. Why just one quasi-synchronous lambda? Because you can expose, it is like the one quasi-synchronous lambda is a placeholder for all your JAX-ORS endpoint. There is no need to deploy another one because you can expose hundreds of endpoints with different URIs. So you are set with that, right? And the asynchronous lambdas, they participate here. They're listening to a S3 event. Usually we use Event Bridge or Kinesis, Kafka, SNS, SQS, AWS code build events, for instance. So this is what happens behind the scenes. So this is the business logic. So we have here, this is the synchronous lambda and this is asynchronous lambda, exactly the same structure, and everything is shipped in one zip. So if we take a look, maybe I built this already. So I go to the lambda in target. So you will find here one zip, function.zip. And in this function.zip, they are all lambdas in one serverless archive, we call it. So good news to all Java developers. In my project, there is no difference to before. 10 years ago, we created a war, and now we create a zip. And since yesterday, I try now to find a name, and this is actually serverless archive. So we can call it this way or not. But I get a question all the time, and the answer is going to be serverless archive, right? Okay, next one. So no, next one. Now the question is how I deploy this, right? So we have the lambda here, and I would like to close this. And what I'm searching for is here is my CDK. So the only problem here is my resolution. So this is CDK, Search for Cloud Development Kit. And what I do is we are coding the entire infrastructure in Java. Why? I'll show you in a second, because if you have Java, you have Maven, and what you can do, you can share constructs and reuse whatever you did, the entire infrastructure across your team. So you can build reusable constructs. So I'll show you how this looks like. So we have this CDK app here. Yeah. And this is Lambda write and listen. This is the app name. And we have the project serverless archive with multiple functions. And this is the environment. And then we have a stack. What a stack is like a infrastructure microservice. So stacks are independent from each other. They should not, if possible, reference each other, and they are loosely coupled. So it is really like a microservice for infrastructure as code. So and the entire deployment is just this. So what happens here? I say, okay, I would like to have a bucket, and I created a new construct. Just invited the name. Invented CDC change data capture bucket, and I need a name for the bucket. I need a writer function and a listener function. What I also need, I need one Quarkus function and one asynchronous function. The Quarkus function is the quasi synchronous function, and the other functions can be whatever functions you like. And I would like to configure the writer function as a function URL. So function URL is like simplistic way to deploy quasi-synchronous functions. The only downside is you cannot get, or you cannot hardly get, a nice DNS name. So this is the downside, but it's very easy. So let's take a look what happens here. So these functions, Quarkus, create Quarkus function. This is just a regular Java interface. So that's all. And because it's Quarkus, what I know is that this is the fully qualified name of the Quarkus. I know, the create function here. Invokes here. I say, okay, I would like to have an ARM. So there are some, predefined conventions. I would like to deploy the zip. And by the way, the other function also deploys the zip. So the same function zip is deployed several times with several functions. So that's what happens behind the scenes. What's interesting is the CDC bucket. So this is a construct, which means it is reusable. I could push it to my Maven repository, and other team members could just download that. What's interesting here, it says buckets create. So what is buckets? Another Java interface. I say I block the access. That is not needed because it's default, but I just want to configure something for more show. Then bucket name and build, and that's all basically. And what I say here is, okay, look, the writer gets read and write permissions, and the reader can only read. And then I would like to tell the bucket, hey, bucket, if someone puts something to you, just, notify the listener. And that's all. So the entire app, everything plays together because everything is in one monorepo. So it's very, very simple. This is how my actually production setups look like. And it works beautifully. So everything is Java. We have code completion, lean code. We can share the code in Maven. We can, perform code review just looking, and this is okay. Looking these permissions. The permissions are generated by AWS behind the scenes, and I'm only depending on AWS. But if I ship code to AWS, it's okay, to be depending just on the infrastructure from AWS, I would say. So this is more or less, a real world example. I rebuild this from scratch. And but it should actually run. And yeah, if you have time, I will launch it for you. It is already deployed, because I think, okay, I have something as a fallback. But before I show you this, I don't have much time. I would like to do the next one, micro constructions. So micro constructions. So this is the thing I talk about that. So there is constructs which are pieces of reusable infrastructure. And what I did here, we have here a reusable construct. So let's take a look at this. I just created a very simple example for you to demonstrate the point. So now, what I have here, I have versioned S3 bucket. And the version S3 bucket just uses the AWS dependency as before. And this is that simple. It's just, a Java class which returns a bucket. Actually, it could be even record, Java record would be nicer, thinking about this. So I will change that. I use actually Java records a lot in infrastructure as code. Not this time, I don't know. I recreated the example yesterday, and a Java record could be nicer. And so we have the bucket is created here. It is versioned and event bridges enabled. That's all. So, and what I do here, I just say Maven install. And the even Maven install versioned S3 bucket, Maven install. So, and the Maven install, it puts the bucket to my local Maven repository. Maven deploy would be in real world, but Maven install is here. And so now this is done. And the cool story is what I can do now. I can go to the another project. So I have just to close the projects. I have the storage app. So, and the storage app here, if you take a look at the POM, you will see that I'm actually including my previously created construct and reusing this. So what it means here now in my app, in my CDK stack, I can now use my version bucket from before. So for Java developers, that we can share jars. But in infrastructure as a service, it is infrastructure as code is a bigger deal. So in this, because I'm serverless now, but in one project we're using Whitefly with ECS Fargate and Aurora database and Kafka, and the construct is larger. But and even VPN connection, there's a set of constructs, and you get DSL construct where you can say create new app, add microservice with memory and database, and then everything happens for you. And you can save a huge amount of time. And the cool story is, again, this is Java, it is Maven. We can use nice IDEs, and we get code completion. And the code is, very lean comparing to, for instance, Terraform, where you will have to write, a far more code, and all the permissions, everything is handled by you because of CDK. Okay, so micro constructs. The next one is BCE for infrastructure as code. I think I'm almost over time, so 10 minutes, I think. So if I'm over time, just stop me, moderator, please. So I will just talk, and if you say, okay, now it's over, then it's over. Okay? Hello?
Yeah, you have 5 minutes, additional 5 minutes.
Oh, very, very good. Thank you. So now we have this. Now we have back to my serverless archive, and Lambda Quarkus, and what I would like focus now on the infrastructure, because the question is how to structure the infrastructure. How to structure the infrastructure. This is a great title for next session. How to structure the infrastructure. So how to structure the infrastructure is this. Take a look. I use the same concept as for business logic and even for the front ends, boundary control entity. So I have the writer here with boundary, and this is serverless application stack. And the serverless application stack is more or less, it is a microservice, right? Because the stack is independent and it just uses controls. This is like the entry point. And there is one which creates buckets. The other one, Corsair Grain, creates the CDC buckets and functions. But we have constructs to create pipelines, deployments. Everything is coded like this in Java. And what means is, but the only, what in larger projects, what I tend to do, I name the components after services. So what I do here, I will call it, for instance, code deploy or code build or a kinesis, or it is easier to find if you maintain the applications, because if you are in the infrastructure space and you would like to change the queue, it is easier to find if you name the packages after you know the service names, which is bad idea in the business, because in the business you don't like to change the queue. You usually would like to change the business logic, and the business logic is not necessarily associated with a queue or topic, rather than with queue topic table, and there is more right to this than in the infrastructure. So my observation is just that in larger projects, the packages are named after managed services, cloud managed services like Cosmos DB, DynamoDB, Azure Container Instance, whatever, right? This way. Okay. Cool. So this was this, and infrastructure as code. This is the smallest possible pattern, but it is surprising actually. So if you take a look what happens behind the scene. So the CDK environment from AWS invokes my Maven projects with that. But nothing stops me to change that and do Java minus jar here. So what it means is, if our infrastructure is provisioned, what we can do, we have the first pipeline, which creates from the CDK an executable jar, pushes the jar to S3 bucket, and this S3 bucket is referenced in the pipeline. The pipeline say, okay, AWS S3 copy from bucket the jar to my local pipeline, and the entire pipeline, infrastructure pipeline, just does Java manage jar, one liner, which is beautiful. No installation of strange things, because in the code build image you already have Java, you already have CDK, so there is nothing to do actually. Okay, now how this looks like in deployment. And by the way, again, whatever I did is on my GitHub account. This was the Quarkus Lambda CDK plane. This was the project I referred to. And if you're interested in the podcasts, so there are podcasts from various about Apache Roller, for instance, was a recent one with Kelsey Hightower is about Kubernetes, and interested in workshops, go ahead here. And okay, calculator, very important. And this is my vmix for the conference. But what I wanted to do is actually to show you the cloud formation. And these are the micro stacks I told you before. So let's see. So you see here, docs, rocks, function URL stack. So this was what we did before. So I can go here and delete the entire thing, because it is stateful. And Lambda S3 write and listen. This is this stack. I provisioned it yesterday for you. And these are my Lambdas here. Wait a sec. So interestingly, I have 4 Lambdas. Okay, so this is my Lambda S3 write and list serverless archive and S3 listener. So there are 2 Lambdas here, and the serverless archive, for instance. So you can see this is the AirHack serverless archive Lambda with this was 20 megs. And wait a sec, configuration function URL. This is my URL. So I will copy this and then try to call it. call this is extreme cold start. Maybe it worked. No, it didn't, because what I forgot is -h content type typical JAX-RS problem. Text plain. Now it looks better. Wait a sec. No. Not better. Oh. I'm not sure about the URI. Wait a sec. You have to wait, right? So let's see. No content. Now it looks good. So let's see. So go to here to my, where is it? No. We have to go to CloudWatch and we have the servers archive. This is right now. So the Quarkus was booted. So we wrote, the in 200 milliseconds, we wrote to a bucket the hello, and the listener, it is now received the data here. So there were two functions in one. This, as you can see, this is the fully qualified name, and it happened right now. So I would say it works. And this is, I would say, the first idea about patterns in the cloud. This is what I'm doing in projects right now, and it works well. I wouldn't call it best practice. I would say it works good enough, and developers are happy. I think I'm over time. So now back to studio, right? So if I have questions, ask me. Exactly, and I compiled the URIs with the articles here. So I sent you the slides and all the references from my GitHub and some YouTube talks about that if you're interested. At the workshops, and thank you, and please donate everyone, right? So this is actually our job here. And if you donate,
Adam,
of course, with one, not two, right? If you donate one, two doesn't work. Okay.
Yes. 2001 or 201 or even one. it would also count. Adam, it was powerful. Thank you for your speech and your demo. I like your coding style. It's pretty fluent. Thank you very much. We have a couple of questions to you and maybe some really generic ones. So how do you solve monitoring and tracing challenges in huge serverless projects? What do you think about built-in cloud capabilities, or you use some external tools? Please share your experience.
Oh, you know me, no external tools, because you have to care about external tools. The problem with external tools is additional complexity, additional costs. So if you have monolithic lambdas, they are easier to monitor because it's just one. If lambda should not call other lambdas via HTTP, this is a bad practice, I would say. If you use SNS or SQS, you can send traces. And not everything is supported. It's called X-ray. AWS X-ray is something like open tracing. And there is a Lambda Power Tools for Java, for instance, an open source project. And this project helps you also with tracing. But for me, there is no difference to standard Quarkus in monitoring. It means huge serverless applications doesn't mean to me that we have 5,000 lambdas. It's more like the lambdas are larger. It's still no problem. And another thing is we have another important thing. What we always do, I didn't mention this today, we have a multi-account strategy. It means we have one service per account. So we split the applications into multiple services running in various accounts, which also makes easier to monitor. And what we also use, we log just with system out print line wrapped more or less to CloudWatch, and that is very easy to create alerts. So this is our strategy, works surprisingly well.
And don't you consider monolithic Lambda as anti-pattern? For example,
Yeah,
it might cause some issues with cold start performance.
yeah. As you saw in my current project, we have 500 classes in one Lambda. It starts in about 2 seconds without snap start. And snap start is new technology from AWS or need AWS. It's actually based on CRAC. CRAC stands for coordinated restore at checkpoint. I cannot remember this. And then the startup time, it is halved. So it is like 1 second. So I don't see correlation between number of classes in a Lambda and startup time. What if you have strange frameworks? So for instance, last year there was a workshop and they showed me one Java class which started in 10 seconds, and I look what's wrong with it, and they had like 5 different logging frameworks there. I don't know why, and they cost the slow startup time but not the business code. And also Quarkus and Micronaut are very fast with startup time, so we never had issues actually with startup time. And you can set also use provision concurrency. So you will pay roughly 20 euros a month, and then your Lambda will be always hot, still cheap. And if you pay for provision concurrency and you call the Lambda a lot, every subsequent call is cheaper.
We have a question also from our audience regarding maybe you can recommend some cloud agnostic infrastructure as a code. Maybe they mean something like Terraform, or you have some other ideas?
I wouldn't suggest that because the solutions are terrible. So I would say I would do this. If I go to Azure, I will pick Bicep. It's a great language at the Azure where you can have proper for loops, if and whatever. If I'm an AWS, I would use CDK. I would say management dreams that we are cloud agnostic, and but we cannot be cloud agnostic because the resources, it means resource, the cloud API on Azure is completely different to AWS. So I mean, doing something in cloud agnostic way is hard, and the question is, we have already the experience with the application servers portability or whatever. So the cloud, this was possible in application servers, but it's really hard in clouds. And what I don't like to be portable. What interests me is the switching costs. What are the switching costs? How long does it take to switch between AWS and Azure? And your business logic is not, depending on the cloud too much. And the question is, we have only to swap the infrastructure. And regardless which tool you are using, the problem is the IAM. This is the identity management in all clouds are different. Networking completely different. The routers and everything. This is what will hold you back, not necessarily the tooling. But having said that, if you really would like to be cloud agnostic for tooling, Pulumi looks the best. There's Pulumi Java edition, and Pulumi is the most interesting, I would say, cloud agnostic solution I know so far.
Thank you. And the last maybe 2 questions. We have still time we can take from the break. So just one small question regarding what do you think? Did you have a taste of Lambda at Edge to solve maybe some performance issues related to different regions?
Yeah, Lambda at Edge, completely different technology, unrelated to my talk. It is a subset of Node.js, JavaScript, Lambda, which runs directly, on almost on location. So it is a remote, on remote outpost. Outpost is a specific name for Amazon. How to call it? Satellites, right? And it can solve some problems if you would like, to set HTTP headers or routing, something lightweight HTTP related front end stuff. This is where I see Lambda on Edge, but not for this what I showed you today. It's more like today is how to build, boring enterprise applications in an efficient way, and Lambda on Edge is, how to optimize front ends.
Okay, and the last one, maybe it's like kind of tricky question. What do you think about project Helidon, which is advocated by Oracle? You used Quarkus, so why don't you use Helidon if it's project under the umbrella of Oracle?
The only one reason, because the Helidon people are lazy. There is an issue which I already, even my podcast mentioned several times. What Helidon cannot do, it cannot parse the HTTP event and pass it to JAX-RS. This is the only reason. What's my personal opinion on Helidon? Helidon is great. Helidon uses microprofile already with NEMA, Project NEMA. It means they combine microprofile with Loom, and this is great because you can start to know millions of threads in no time. So I like Helidon a lot. I miss one crucial point, and there was an open issue, but it is really easy to implement as well. But they I don't know, maybe it has to be hopefully it is prioritized, after this event. Maybe Oracle listens, so please do it. Then I will use Helidon more, because I actually don't care. I don't like to be depending on Quarkus either, right? I would even use Micronaut more, but Micronaut does not support all of microprofile, and most of my projects are migration projects, so I get a little bit in trouble with Micronaut. But for what I showed you today, it would beautifully work with Micronaut. So Helidon, Micronaut, and Quarkus are great. Quarkus is most popular and most compatible with Java EE. This is what I did all the time. So for migration projects, I prefer Quarkus. I would really look forward to use Helidon in the cloud, but the functionality is missing, which translates HTTP events into JAX-RS resources. But Helidon is great. You should try it. So there's very innovative project. The team is great. The people from Java EE times is very compatible microprofile environment and really nice.
Thank you, Adam. It was fruitful discussion and definitely great demo. So I would like just to see you next time at any conference.
Sure.
You are brilliant. Thank you very much. I personally enjoyed your speech.
Thank you. If you have any question, keep asking me on Twitter or in Discord. Join Discord, ask me, and I will answer this in the next AX TV. So I just like conversation, right? Should be fun.